here's how it works. A separation problem. It looks like this has. Don't write that. A differential equation. I'm going to abbreviate. The differential equation is separable. When it is of the form, it is of form f of y dy equal to g of t dt. So right off the bat, you should say that is of no value, because we haven't seen a differential equation look like that, have we? All of ours say y prime equals something. And so this is our goal form. I'm going to put it this. This is our goal form. But a simple bit of algebra will give you the form that you're usually first greeted with. Initial form. Initial form. It usually looks like this. Because remember, a differential equation is about a derivative, dy dt, equal to g of t over f of y. So today what we're going to do, since we haven't done a lot of, we're going to just try 1, 2, 3 examples to work with this. 3 examples. So here's how they work. And there's a few things I want to point out along the way. How about this? Oh, you'll love this. How about solve y prime equals ay. Remember that? That was day 1. You're like, really? It's been 8 weeks and now you're going to just solve that. I don't know. Maybe I'm just going to pick a number that felt close. Solve that. So right off the bat, let's take a moment and think about, we're kind of in this form, aren't we? We're really in this form right here. Y prime equals ay. So let's do this. I'm going to write it in the form that we need, and we need this as dy dt equals ay. And then, from there, what we need is this. This is our goal now. And that is all the functions of y have to be on the left and only have y in them. And all functions of t that only have t in them have to be on the other side. In our second half of class today, we're going to find out what happens if this is also a function of t and g is also a function of y. So right now, this is what we can do. We could rewrite this as, I'm going to write this as 1 over y dy is equal to a dt. You see, we're just doing some multiplying of fractions. Multiply both sides by dt and then divided both sides by y. And now I'm in this form. So in this case, here's f of y is 1 over y. G of t is just a constant a. And I have it in this differential form. And then it's surprisingly, this simple. Just integrate both sides. So you integrate 1 over y, and we're going to do this problem. Oh, we'll do one of these two. Dy is equal to the integral, and let's put in our limits of integration. So let's go from y of 0 to y of t, and on the other side we're going to go from 0 to t. Normally you change this to a ds. Yeah. I don't know what they taught you in 3B, but probably. Yeah, I haven't taught it. I taught it once this long time. It might be. It probably is. It's kind of the easiest way to solve differential equations. Did they teach it to you guys before? Probably. Yeah, this is usually like the starting round. Let's see. Oh, so if I integrate this one gets kind of interesting. Notice that we'll write our steps. We have on the left-hand side, we have the natural log of y, or the function of y, minus the natural log of y of 0 equals and then this becomes a times s evaluated from 0 to t, is that right? So a s evaluated from 0 to t, so we can just write this as a. If I make a mistake, let me know. Okay, I'm going to add. So remember, our goal is to find a function of y. So let's solve this for the natural log of y. So I can write this as natural log of y is equal to the natural log of y of 0 plus at. So this next step, it's not hard, but it is easy just to make a simple mistake. And that is, in order to solve for y, what would we do? Right, we're going to raise both sides to e, the inverse of the natural log. And so when I do that, what I get is this. I get y on the left-hand side, and then I'm going to write out my steps so you can see this. I'm going to get e raised to the natural log of y of 0 plus a times t. And then let's use our rules of exponents. So we can write this as y equals e to the natural e raised to the natural log of y of 0 times e to the a t. One last step, what would that be? What is e to the natural log of y of 0? Well, this is be y equals y of 0 times e. And is that the solution that we expected? Yeah, that's the solution that we expected. Now we're going to do it one more time, and then we'll try some more interesting ones. And I'm going to try to answer a question that keeps coming up in our study sessions, and maybe make this a little bit more clear. So notice here, we were using our strict applications of calculus, and we had limits of integration based on where our starting values were and our ending values. And this it's usually you start at y of 0. That's when usually a problem begins. It doesn't have to. Sometimes for it just to be interesting, it could be y of 1. And so you could go from y of 1 to y of t and from 1 to t as well. So that's possible to do. But here's another way that you'll see this done, and you need to see it. And that is without the limits of integration. So let's do this again. I'm going to write this again. Without limits of integration. I'm going to go dot, 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 because then what we're going to do is we're going to pick up right here. Bring that over. So I have, we write 1 over y dy equals a t t. And so again, we're going to integrate both sides. Integrate both sides. If you do that, we have the natural log of, I'm sorry, the integral of 1 over y dy equals the integral of a, and I'll just write dt because we're not even worried, we don't even have variables that will be substituted in. So again, we know the answer to this. So what you would normally write is something like this. You'd write, okay, well, the integral of 1 over y is the natural log of y plus some constant equals, this equals a t time plus some constant. Then what do you want to do with those c's? You want to scrub them, don't you? But you can't. So I'm going to be, so this is what you were taught when you first dealt with indefinite integrals. But here's the catch to the problem. These are different c's. So you can write them or think of them as c1, c2. So I'm going to clean this up. I'm going to write this. We're still solving for y, so the natural log of y equals at plus c2 minus c1. But it gets even better. C2 minus C1 is just another constant. And so what we do is we say, all right, let's just clean that up and we'll just call that C3. So now I have the natural log of y equals at plus C3. Then we take the exponential of both sides, so I have y equals e raised to the a t plus c3. I'm going to break it up again into, I'm going to switch, oh no, this way, e to the a t e to the c3. And I'm going to just switch the order for a moment, okay, and then I'll pause and let you catch up. E must be e to the c3 e to the a. This is where we're going to stop this. Yeah. Oh, that's for me? Sweet. Oh, I just saw it.